The most difficult cross-sea cluster project in the world to construct. How difficult is it to construct the Shenzhen-Zhongshan Channel construction project? In this video, let us learn more about it. As the most difficult cross-sea cluster project in the world to construct, the Shenzhen-Zhongshan corridor lets the world know what Chinese-style infrastructure is. Can you imagine that it only takes 15 minutes to get to Shenzhen from Zhongshan? This is so convenient. Maybe some friends want to ask, it's just a passage. Hasn't China already built many world-class projects? Why is this deep and middle passage worthy of being discussed in detail separately? In fact, the reason lies in the word tunnel included in the Shenzhen-Zhongshan tunnel project. As a world-class project, the Shenzhen-Zhongshan tunnel is 24 kilometers long and mainly includes 4 engineering projects: bridge, island, tunnel, and underground interchange. The bridge refers to several bridges such as the Lingdingyang Bridge, the Zhongshan Bridge, and the East African Navigation Bridge located on the right side of Zhongshan. The island refers to the 2 artificial islands built on the sea between Zhongshan City and Shenzhen City. The tunnel refers to the most difficult undersea tunnel in the entire project. Underwater interconnection refers to the underwater interconnection facilities established on the East Artificial Island, near Shenzhen, that are directly connected to the airport. The Shenzhen-Zhongshan Channel is a channel that connects the above-mentioned bridges, 2 artificial islands, undersea tunnels, and underwater interconnection facilities. The reason why the construction difficulty of the Shenzhen-Zhongshan Channel ranks among the top 10 in the world is not the cross-sea bridge, nor the 2 artificial islands, nor the underwater interconnection facilities that sound awesome. But it sounds simple, but is actually as difficult to implement as an undersea tunnel to dock a spacecraft in space. What are the difficulties in building an undersea tunnel? How to prevent seawater corrosion in the immersed tubes of undersea tunnels? Let's first understand why such a section of undersea tunnel must be built on the Shenzhen-Zhongshan Channel. Shenzhen-Zhongshan Channel is a cross-sea channel connecting Zhongshan City and Shenzhen City. Why do most passages starting from Zhongshan City choose to build bridges to connect them, but when reaching Shenzhen City, they must build more difficult undersea tunnels? In fact, there are 2 main reasons for this. The first is that there are many waterways in the sea near Shenzhen, and many large ships often sail in the waterways. If a bridge is to be built, the passage of these large ships must be considered. In addition, the cross-sea bridge itself also requires extremely high tower bridges to support it, so if it does not affect the waterway, the tower bridge of the bridge near Shenzhen must be built very high. Then there is the second reason. There is Baoshan Airport at the end of the Shenzhen passage. This Baoshan Airport is only 3 kilometers away from the end of the channel, and a large number of planes take off from Baoshan Airport every day. This means that if you want to avoid affecting the normal flight of these aircraft, the bridge towers near Shenzhen must not be built too high. Looking at it this way, don't the 2 contradict each other? If they choose to build a bridge, the bridge must be raised higher to allow ships to pass, but this will affect aircraft. Finally, after various considerations, the engineers decided not to build a bridge on the sea at all, but to build a tunnel under the sea so that it would not affect anything flying in the sky or swimming on the sea. But even though that is said, the difficulty of building a bridge on the sea and building a tunnel under the sea are very different. First of all, engineers had to consider what materials and shapes of tunnels can withstand the pressure of 30 to 40 meters on the seabed without deforming. Secondly, even if the tunnel is paved, how can they ensure that the tunnel will not be corroded by seawater? Unlike semicircular tunnels that are common on land, tunnels located under the sea have to withstand both the heavy pressure brought by seawater and the traffic pressure of ships above them. Therefore, engineers must take the pressure-bearing issue of the tunnel into consideration when designing. Finally, after many experiments, the engineers decided to use a rectangular tunnel. One is because tunnels of this shape can better withstand the pressure brought by seawater. The second reason is that only this shape can more conveniently complete precise docking in seawater. Think about it, if they want to connect the curved circular tunnel under the sea with an accuracy of a few millimeters, the difficulty will probably be doubled. But just confirming the shape is not enough. The most important thing is what kind of materials are used to make the tunnel to maximize the tunnel's pressure-bearing capacity. This problem also caused a lot of headaches for engineers. But China infrastructure has never given up. As a result, the steel shell concrete immersed tube tunnel appeared. Steel shell concrete is actually a structure that first uses a large number of steel plates and welds them into a hollow steel shell, and then injects concrete into it. It can also be thought of as a sandwich with 2 layers of steel on the outside and concrete in the middle. It's just that the sandwich shape of the immersed tube is rather special. It is welded by 2 layers of inner and outer rectangular steel plates. Moreover, more than 2,000 compartments are separated between the double-layer steel plates. The more than 2,000 compartments are where cement is poured. Making an immersed tube in this way not only increases its strength and stiffness, but also makes it less susceptible to compression deformation. Through experiments, engineers found that the pressure-bearing capacity of immersed tubes manufactured in this way can exceed tens of thousands of tons. In other words, even if tens of thousands of cars are pressed on this material at the same time, it cannot be deformed. It is perfect for making undersea tunnels. After the materials have been selected, all that remains is to lay the undersea tunnel. Because the submarine part of the deep and medium channel is about 6 kilometers long, engineers divided it into 32 sections, each of which is connected by an immersed tube about 165 meters long. But it's easier said than done because these immersed tubes are extremely heavy. The total steel consumption of the 32 immersed tubes is about 320,000 tons, which is 3 times more than the bird's nest. The average steel consumption of each immersed tube section is 10,000 tons. And this is only the amount of steel, not counting the concrete poured later. If counted together, the weight of each immersed tube section can reach at least 80,000 tons. What is the concept? Everyone knows about the Liaoning aircraft carrier, but even the Liaoning has a displacement of only 54,000 tons, and the weight of one immersed tube already exceeds the aircraft carrier. To transport such an immersed tube weighing tens of thousands of tons to the sea, it must be accurately placed at the predetermined tunnel location. Just think about it and you will know how difficult it is. To this end, the R&D team continues to improve the existing self-propelled semi-submersible vessel so that it can smoothly transport immersed tubes and complete installation. From 2013 to 2017, for 4 full years, the R&D team continued to try and make improvements, and finally, Ehang Jinan No. 1 was born. It is equipped with 2 sets of 9,280 kilowatts propulsion systems and 8 high-power side thrust systems. Such a huge power system allows it to carry tens of thousands of tons of immersed tubes and sail freely in the sea. In addition, the docking problem of immersed tubes was also solved by Ehang Jinan No. 1. because it is also equipped with a fully automatic ship stabilizing function and a pulling system. These two are enough to allow it to lower the immersed tube and complete the docking in the designated sea area. So on June 17, 2020, Ihang Jinan 1 finally officially began to perform its mission, and successfully brought the first immersed tube to the sea near the west artificial island of the Shenzhen Zhongshan Channel, to complete the docking with the dark section. From this day on, the project of laying the immersed tube of the undersea tunnel officially began. By June 11, 2023, all 32 sections of immersed tubes have finally been connected, which means that the subsea tunnel section of the Shenzhen Zhongshan Channel has finally been officially completed. Judging from the current official construction plan, engineers have adopted triple protection to prevent corrosion of these submarine immersed tubes. The first step is to reserve corrosion thickness. To put it simply, when manufacturing immersed tubes, an extra part of the steel plate is left on the outer layer to withstand the corrosion of seawater. Even if this part of the steel plate is corroded, it will not affect the strength of the immersed tube itself. The second step is to increase the coating and spray the outer steel plate with special anti-corrosion paint. This kind of anti-corrosion paint is called epoxy glass flake anti-corrosion paint. Because this anti-corrosion paint itself contains more than 80% solid content, it can be closely combined with the steel plate of the immersed pipe to form a protective layer, isolating the contact between the steel plate and seawater and preventing seawater from corroding. The third level is sacrificial anode and cathodic protection. That is, silver-white core blocks made of metals such as zinc or aluminum are connected with cables on the outer steel plate of the immersed tube to form an electrochemical system. Whenever these pellets come into contact with seawater, the seawater will enter the electrochemical system as an electrolyte, and the pellets will undergo an oxidation reaction to sacrifice themselves to protect the steel plate from oxidation. It is understood that there are at least 522 such core blocks distributed on each section of the immersed tube. They are also the first line of defense to protect the immersed tube. Therefore, in fact, before the official laying of subsea immersed pipes, engineers have already completed triple seawater anti-corrosion measures. Up to now, the construction of several major bridges on the Shenzhen Zhongshan Channel has been basically completed. The construction of the east-west artificial island structure has also been completed. The underwater interconnection facilities have been formally formed, and even the most difficult undersea tunnel has been laid. In other words, the construction project of the Shenzhen Zhongshan Channel has entered the final stage. This not only shows that China's infrastructure has overcome another world-class construction problem, but also represents that China has once again completed an infrastructure miracle. Thank you for watching. If you enjoyed this video, don't forget to like, comment, and subscribe to our channel for more great content. See you next time.